a circular rod of diameter 16 mm. So diameter is 16 mm and 500 mm long. So length is 500 mm. 500 mm, right? So this diameter is given as 16 mm. The length from here to here, this length is given as 500 mm, something like this. Okay. So is subjected to a tensile force of 40 kilonewton. So P is given as 40 kilonewton. We'll keep it as it is, 40 kilonewton. So kilo basically stands for 10 raised to 3. So if you want, you can write down as 40 into 10 raised to 3 newtons or simply 40 kilonewton, no problem. So load P is given as 40 kilonewton. The modulus of elasticity of steel may be taken as 200 kilonewtons per mm square. It is Young's modulus, so we'll take E. E is given as 200 kilonewton per mm square. Now here there is a very important point to remember. So here the load is given in kilonewton in the modulus of elasticity, as well as here also in kilonewton. Okay. So same unit for the load to be followed. Okay. You should not follow at one place kilonewton and other place only newton. Okay. Then you'll get wrong answer. You should follow same unit for load. Okay. So that is correct now. So here we got 200 kilonewton per mm square. This is the given information we have, or data we can say, and then we have to find. The first thing we have to find is the stress. Stress is question mark. Then but stress is what basically? Stress is load divided by area. Here load divided by area of cross section, right? Area of cross section is A. Load divided by area. Second thing we have to find is strain, right? Strain. So strain is nothing but change in length. There is deformation divided by original length. Second thing. And third thing, they are asking us to find out what? Elongation. Elongation. That is deformation they are asking us to find. Elongation is nothing but delta L. As you know, delta L, we have already derived the expression for delta L. It is P times L divided by area times modulus of elasticity or Young's modulus. Okay. So these are three things we need to find here. Okay. Now, so we can initially start with the load upon area of cross section. The load is directly given 40 kilonewton divided by area of cross section. Here diameter is given to you, so you can, from diameter you can find out the area of cross section A. A is nothing but pi by 4 into d square. Okay, we can easily find out the area of the circular cross section by pi by 4 into diameter square. So that value will come here. So you get 40 divided by pi by 4. So instead of d we should write down as 16 square. Okay. So stress is given by load divided by area of cross section. So load is 40 kilonewton and this is pi by 4 into d. D is 16. So pi by 4 into 16 square. So you can solve for it. If you solve this value, this will be simplified as 4 will go up, 4 times 40. The value of pi will be 3.14 you can use, and then into 16 square. So whatever value will come, that will be coming in the kilonewton per mm square, right? Because area is in mm square and load is in kilonewton. Okay. So let's simplify. Therefore, stress will be, if you solve this particular value, you'll be getting something around 0.198 kilonewton per mm square. So now the next value is we have to find is the elongation, because to find the strain we need delta L. So delta L is not known to us, right? So delta L is not known to us. So first we'll find the elongation. So P is 40 kilonewtons. So I'll put 40 only. Length is 500. Okay. So length is 500 mm. Area of cross section is pi by 4 into diameter is 16 mm in square. And modulus of elasticity they have given as, you can see here, modulus of elasticity they have given as 200 kilonewton per mm square. So 200 will write. Again we are writing E also in kilonewton per mm square, and here load is also in kilonewton, so there is no issue. If you solve this value, you will be getting the value of elongation around 4977 millimeters, right? And then if you substitute the value of delta L in the expression of strain, so now if you put the strain, if you put the value of delta L in the strain, you'll get delta L as 0.497, that is elongation, divided by original length. Original length is given as how much? 500 mm. So divide by 500. If you solve for it, you'll get so 9.95 10 raised to minus 4, and there is no unit for it because it's a unitless quantity. So overall, we got the value of strain, we got the elongation, and we got the stress.